Today's daily LeetCode problem of the day is shortest subarray with or at least k, part 2, number 3097. For this problem, an or is an or function, which is kind of like a Boolean expression, except we're using it on the bitwise representation of numbers. So for this problem, we're given an array nums, and they are non-negative integers, and we are given an integer k. So an array is called special in our case if the bitwise or function of all of its elements is at least k. So k is a value. We want to be greater than or equal to. We want to return the length of the shortest special non-empty subarray of nums. And we're going to return -1 otherwise if it doesn't exist. So let's review what an OR function is. So an OR function is used with this standing. It's similar to the Boolean, which is 2 of these standing lines, but the single is an OR function. So for this OR function, it's looking at the bitwise expression of numbers, and we can see this by using 5. The bitwise expression will be 0, 1, 0, 1, and the bitwise representation of a 3 is 0, 0, 1, 1. So let's say we are going to OR this function. When ORing this function, we are going to basically check and compare the bits in this function. So similar to a Boolean expression, with a 1 or a 1, the outcome is a 1. With a 0 or a 1, the outcome is a 1. With a 1 or a 0, the outcome is a 1. And only if we have a 0 or a 0 will the outcome be 0. So it's kind of like a true or false OR expression. So if it's true or true, we return true. If it's false or true, we return true. If it's true or false, we return true. And if it's false or false, we return false. It's as simple as that. So using this logic, we are going to use a sliding window technique along with some bit manipulation. And we'll do this by having a window start variable and a window end variable. And as we slide our window end through the array, we're going to expand the window. We are going to keep track of the bitwise OR value. So if we OR 5 and 3 together, we will actually get, if we OR 5 and 3 together, we will get 7 because the bitwise representation will be 0, 1, 1, 1. And we got that by ORing 3 and 5 together. So we're going to OR 2 values together, and we're going to keep this in an array called bit counts, and that's going to count the set of bits at each position. Once we have a valid OR value, meaning it's going to be at least k or greater than k, we will attempt to shrink the window from the left and adjust our bit count accordingly. We will track the minimum length of such window and return the smallest one we can find. So let's go ahead and jump into this code. First, we're going to identify a couple values. So we're going to have an integer n, which is going to be, we're going to have an integer minimum length, which is going to keep track of the minimum length of our subarray. And we will equal that to the max value. So that way, whatever we come across will always be smaller. We'll then have an integer left, which is going to be our left pointer in our window, and an integer right, which is going to be the right pointer in our window. Then we'll have an integer array called bit count, and that is going to be a new integer of 32 length, meaning that we have 32 bits, and we're going to keep track of how many bits we have in each position to make sure that we have k or greater numerical value. So we're going to expand our window until the end of the array, and then we will add each of these numbers to our bit count. So while right is less than our num dot length, we are going to update our bit count. So we're going to call to a helper function And this helper function is going to update our bit counts. So we could call update. We'll pass it our bit count and whatever number we're on. So nums of right, and pass it the initial position, or 1. We'll then contract our window while our OR value is valid. So if our OR value is k or greater, we will shrink the window because our goal is to find the smallest possible subarray. So while our left pointer is less than or equal to our right pointer, and we're going to call to another helper function, which is going to translate our bit representation to a value to check if it's greater than k. So we're going to call convert, and then we could pass it our bit count. And as long as that number returned is greater than or equal to k, we are going to shrink our window. We're going to do that by updating our minimum length first. So min length is going to be equal to math.minimum of min length and right minus left plus 1. And the reason we're doing plus 1 is because it's a 0 indexed array. So we don't want a 0 length, or else it will return -1. So we're going to have right minus left plus 1. Then we can call to our bit count to update our bit count as we're removing the leftmost pointer. So we're going to call to update again. We are going to pass it our bit count, our whatever number our left pointer is on, and 1 again. Sorry, -1, because we're removing it. And then we can increment left. So left will move in 1 as we get rid of that leftmost number. So then we can return our min length. If it's equal to integer dot max value still, we will return -1. That means we did not find a small subarray. Otherwise, we can return our min length. So that's it for our code. We initialize our left and right pointers. We expand the window to traverse the array, and once we reach an OR value that's greater than or equal to k, we will try to shrink the window from the left side to find the shortest subarray. Inside of this, we are going to have an update bit count and a converter. So let's go ahead and code our update bit count, as that is going to update our array that is storing all of our bits. So we're going to have a private void called update. It's going to receive an integer array called bit count, integer number that we want to add in this case, and an integer delta. Delta is going to tell us whether we are adding or removing. So for each integer in bit position is equal to 0, as long as bit position is less than 32, bit position is going to increment. We're going to check if the bit is set at a current position. So if number shifted to the right by bit positions and both are equal to 1, not equal to 0, then we can increment our bit positions by delta. So bit count of bit position will plus equal our delta. So what is going on here? Bit position is simply going to be checking bit position is going to be checking each position of our bit array. And if our number, so let's say our number is 5, so the bit representation 0, 1, 0, 1, we're going to check each bit in our number by shifting the bit position in that number. If both are equal to 1 and not equal to 0, meaning that we have a 1 and a 1, aka bit position is equal to number bit position of 1, we can increase that bit by our delta. So when we're adding a number, we're going to send it a 1. When we're removing a number, we're going to send it a -1. This is our bit manipulation part. We're simply checking, hey, this is a 1. We want to make it a 1. So it's not equal to 0, we can increase it by delta. That's all that's going on there. That is our bit manipulation to ensure that we keep track of all the bits in all of our numbers. Then we're going to do our converting function. So we're going to have a private int convert. We're going to pass it our integer array bit count. And we're simply going to have a result. We're going to go through for int I is equal to 0 as long as I is less than 32. I can increment. We're simply going to convert our bits to a number. So if bit count of I is not equal to 0, then result will or equal 1, shifted left by by I. And then we can return our result. So this is simply updating result by adding a 1 in its bit format for each integer of I if there's an I in the bit count, or if there is a 1 in the bit count. Then we will return this result. So if we run this, so this passes our test cases, and if we submit it, passes all solutions. Thank you, and follow up for more daily LeetCode solutions.